Okay, friends. So we are recording everybody. So welcome everybody to this workshop on SRE site reliability engineering. Friends, before we get started, let me introduce myself. My name is Roshan Kumar. I am with ESA from last 6 years. Uh, I have overall 18 plus 6 years experience in IT. Started my career as a Java developer and then I have been into various SUS. I'm currently working as a principal SRE engineer. All right. On the cloud part, I have certification on multiple cloud, AWS, Azure, GCP, and OCI, Oracle Cloud Infrastructure, if you know that. Right. So I have spent around 6 years into Java performance engineering, troubleshooting applications, right? And that's where I have currently into this role as principal SRE with one of the reputed giants of the world. Okay. So that's background about me, friends. So the agenda for today's discussion is that we will understand about SRE role. What is SRE? I believe all have joined today. Are looking forward to know more about this skill. You are already working as an SRE engineer, or you may be planning to, aspiring to become an SRE engineer, and you want to learn more about this role, what it offers, what skill sets is it needed to become this SRE engineer, right? So we will go over this. So that's the agenda for today's discussion. We'll have a quick introduction, friends, because we don't have a lot of folks. So we'll have the quick introduction. It's easy with smaller group. So Ranganath, can we get started on you? Can you just brief about your experience, what you're
Thank
looking forward from this course, right? Just yeah, quickly. Thank you.
Hi, Roshan. Good evening all. So this is Rangnath, around 10 years of experience in QA, around 8 years experience in performance testing and engineering. So I'm looking to transit my career to an SRE. So I didn't get opportunity to work on SRE side, but I'm looking to learn actually what exactly happening on engineering level on SRE side. So that's why I joined this session.
Perfect. Thank you, Ranganath. We will definitely have some insights today for you.
Yeah,
Thank you.
thank you.
Kaveri, can you introduce yourself?
Yes. Hi, Roshan. This is Kaveri. So currently, I'm working as a performance test engineer in one of the big four companies, and I want to become an SRE. So that is why I've joined this session today.
Sure. And your overall experience, Kaveri?
It is around 7.5 years.
Okay. So you're currently working as a performance engineer there.
Yes. Yeah.
Perfect. Good to know about you, Kaveri. Thank you so much.
Thank you.
Okay.
Thank you.
Yeah, Soma Srinivas, if you can hear me, could you introduce quickly? Okay. If Amardeep can hear me, go ahead.
Yeah, hi Roshan. Can you hear me?
Yes, yes.
Yeah, good evening. Yes, so my name is Amardeep Patil. I'm working as an automation tester. I have overall 5+ years of experience in this domain, and this is what exactly I was looking for. I was exploring this option, and like I want to know what is SRE and what role and responsibility of SRE. So that's why I joined here.
Perfect. Good to know about you,
Yeah.
Amardeep. Okay. I believe Kalpana, you are next. You can hear me.
Yeah, Roshan. Hi, Roshan. I'm Kalpana here. I got like 10 plus years of experience in QA. I was working as a SDET, and I'm just I want to explore SRE. I don't have idea about it. I just that's why I joined.
Perfect.
I'm looking for.
Perfect. Good place. If you don't have any idea as well, no problem.
Okay.
As long as you are associated with QA, we can relate in some time.
Okay.
Right?
Okay.
Perfect.
Thank you.
Welcome, Kalpana. Okay.
Thank you.
Okay. I don't know the name. It's showing as RJ. If you can introduce, or Kumar, if you can introduce. Yeah.
Yeah,
Hi.
yeah, hi, Roshan.
Go ahead one by one. Anybody? Yeah.
Yeah, yes,
Okay,
Kumar,
let
you
me
go
go.
ahead. I will.
Okay, sure. Yeah, hi, my name is Kumar. I have around 10 plus years of experience into the performance engineering. And I would like to understand the what is SRE and what are the employment opportunities and what are the key benefits if I move from the performance engineering to the SRE. So
Right.
that's the reason I joined this call.
Sure, definitely. Kumar, we will definitely look into that. But just if you can, on the job opportunities, one of the better place is on the LinkedIn. If you can go over LinkedIn and just search for the SRE, you would get to know more about the role as such, right? Let me just
Mm,
take you to the LinkedIn. And if I
yeah.
just search for, let's say, jobs, if I search here, let's say, and I search for SRE, let's say, site reliability. It's been quite some time I have been here, so let me just check it.
Mhm.
Okay, let's see. So you can see that, right? We have a lot of opportunities in Microsoft, in Nvidia, right? In London Stock Exchange Group, in IBM, and other companies, JP Morgan, Oracle, and
Yeah.
Infosys, right? We have a lot of, so we'll understand, like look at this GE, Phone Pay. There are so many places we have, so that's why it is booming up this particular skill, and rightly so. You'll understand that because it handles a very important role in the IT. So we'll go over that. Okay. Okay.
Yeah,
Welcome.
what I would like to understand is like
Hmm.
as you know, like I'm currently in a performance engineering team.
Right.
So what is the major difference between these two?
Right. That's one of my agenda. We will go over that, Kumar.
Yeah, thank you.
Perfect. Okay. RJ.
Yeah, hi. My name is Ramesh.
Okay.
I'm a performance tester, so who have experience in load runner and JMeter. So I just joined this course to understand how much coding knowledge we need to work on this SRE. Any automation engineering we need, knowledge we need. So just to understand that, I have joined this
Perfect.
call.
Okay. Okay. Perfect. Good to know. I have noted down your questions. So give me some time. I would like everybody to give half an hour to me, and your most of the doubts will be cleared. And still, if you have a question, please feel free to ask me in 30 minutes. Okay. So we are discussing about couple of skills here, right? We discussed about performance engineering. We have performance tester, right? Have joined this group. We have QA functional engineer, I would say. When I say QA, I mean functional. Performance are basically the non-functional, right? Performance security are non-functional. So I'm calling it non-functional. Is it non-functional part? I hope everybody understands the difference between functional and non-functional because most of us here in from IT.
Yeah.
And then we discussed about performance engineering role. And then we have something called DevOps role. There's one more skill is there called DevOps engineer. I would like to also put this here. And then we have something called SRE engineers. Very important this understanding, right? We have something called SRE engineers after that. So where does it fit? Where we fit here, right? So let's understand about this first. We'll start from here, and so that we can take this better. I think most of us can relate because we all are from QA background. Most of you from performance testing engineering background, and we'll understand about the DevOps roles and responsibility, right? And then we'll come to the SRE part. Now, as you all know, QA functional, they are responsible for the quality from the functional validation perspective. Right? If I talk about any application, let's say make my trip. So this application is working as expected or not, right? When I click on this URL, my page is loading or not, right? The UI. When I click on hotels, whether I'm able to get the hotels page or not. When I'm in the flights, I'm able to log in or not, right? Whether I'm able to register or not. These are functional validations, right? The business functions. When I search for the flights, I am getting the result or not, right? When I'm able to book the flight or not, able to cancel the flight or not, right? Modify my ticket or not. So they are functional validations. And now we can do through manually automation using Selenium, right? We all understand about the QA functional part, right? We all understand this. So I'm not going to spend a lot of time on this, friends. Let me know for any questions. Please note this. We will come to your question. Now we have something called performance testers. And then we have something called performance engineers. What is the response? What is the difference here? That itself a big difference. Together we call it performance engineering. Performance engineering is together we can call this. But what is the core difference here we're talking about? See, I would say performance testers are like 3-4 years experience, 2-3-4 years experience, and they're good at load testing, simulating load. See, one of the important things about performance engineers or testers is that we should be able to simulate load, prod like load in lower environment. That's what we do, right? We try to simulate prod like load depending on how much infra I have based on the same ratio. If I have the same prod infra, I can simulate same prod load. If I have half prod infra, right, I can simulate only half. So depending on the ratio of infra, we can simulate some load, right? So that's what we do. So here the core responsibility is the scripting. You can do scripting in JMeter, load runner, Gatling, Locust, right? And simulate load. We simulate load. Understand the requirement, obviously. Understand the non-functional requirements, the critical use cases, and simulate load. And then try to understand about the application. Try to run 1 hour test, long duration test, endurance test, stability test for 2 days, and try to understand, is my application breaking? Is how my application performing? So that if the same code goes to prod, that's how my application will behave. So performance tests are mostly to do with the simulation part, and they capture some metrics, response time, errors, right? So 2, 3, when you start your career, you do that, right? Now, when you progress in your career or when you get more exposure, you try to figure out the root cause, the problem. Let's say you found one problem. Let's say when you simulated the load, you are started to think rationally about the problem. You develop troubleshooting experience. Finding the root cause analysis, you're doing RCA, you are doing troubleshooting of the problem. That is when you transition from performance testers to engineers. Troubleshooting, issue troubleshooting you do. We try to get to the root cause of the problem. Try to recommend what could be done, recommendations, what to be done from the performance side to make things better. What type of issues? Let's say you simulate load and you found response time is high. Is it application issue? So which layer? So we need to understand, as a performance engineer, we need to all understand the architectural understanding. We should understand the architecture of the application. That's one of the very first thing, right? We should all understand what all do we have components. Do we have web server, app server, database server, or do we have more components? For example, if I talk about make my trip, I have this web server. Definitely I see the web server. And then when I click on search operation, I'm doing some calculation. Then it must be done through some logic server. Search. We are making API calls to all the flight carriers. I'm getting the response in some JSON XML, and then make my trip is doing formatting. We are parsing all the response, and then we're displaying in a human readable format. we are doing. So it must be having a database where when we order the book the ticket, you go to insert to the database, right? So we should have the understanding of the architecture, what all different components are involved, so that it helps to troubleshoot things. So when you start thinking in these directions, the problem, the root cause, from the architecture perspective, what could have gone wrong, just not reporting. Okay, response time is high. When you are looking, when you are drilling down on the root cause, that's where the skill of a performance engineer comes into picture. When you simulate the lower report, publish the result, problem with problem, and you are not putting more details. Your performance testers, you're giving the result. It's useful for some senior folks in their team or looking into for analysis. They need to understand the problem. Somebody would look into all the metrics, right? So performance engineers, we should have the good understanding of the architecture. They should be good at root cause analysis. They should be good at troubleshooting. They should be good at recommendations, performance recommendations. What could have been done better? Let's say I found a response time high, and I know the infra is the problem. Infra contention is the problem. So how much ever I tune my code and my database, if my infra is the problem, and if I'm thinking about I'm tuning my code and the database, will it solve the problem? No. If you have missed out on some basic configuration, and if you are not thinking toward the right direction, you will never get to the problem. It's like, friends, I hope everybody understands the problem. Response time high, CPU high. Is it the problem or is it the symptom, friends? What do you think? Asking, just think rationally. Okay, don't worry. Okay, I am not going to be judgmental here. Just think rationally. I just want you to think. Response time high, CPU high. Is it a problem, root cause problem, or is it a problem or is it a symptom of a problem?
It's a
It's a
symptom
symptom
of
of a
problem.
problem.
Symptom. Fever. Coming fever is not the problem. When we get fever, that's not the problem. When we get cough or infection, we get fever. Fever is a defensive mechanism of our body. Fever is not the problem, right? So high CPU, high response time, high status code is not the problem. They're symptoms. We need to find a root cause. Where is the problem? And that is where we analyze application. We should have the thorough understanding of the application. We should think deeper on the architecture, the request flow. If this page is not loading for me, and if I looking into the web server, wherever the problem is on the database, will it help? If the root cause is on the database and I'm fixing the web server, will it help? Definitely not. Right? So that's one of the very important skill, troubleshooting, as performance engineer we develop in our career. When we look into the problem, when we start digging into the problem, thinking, you need to spend time. Nobody can teach you this, right? Spoon feed you this. You have to do your due diligence to transition. That's where this skill is not a very straightforward skill, right? Not everybody can become a good performance engineers. Not everybody can troubleshoot the application because it does not follow a fixed pattern. Okay, do this and get things done. No, the problem could be of any type. The network problem, the problem with the network can cause slowness. If you have given less heap, let's say you have a Java application, you given the less heap and you are staying out of memory, you cannot say that every time it's a memory leak, right? So we get involved in such things, friends. And we do recommendations that increase the heap, increase infra, do SQL tuning. If the problem with the database, we tune the database, right? If the problem with the code, we work with the developer to fix the code, optimize the code. If one transaction is taking higher time, so that's a very in detail thing, right? So that is what the performance engineer usually do, right? Clear so far? Any questions so far? I'll stop for a minute. Are we good on the same page, everybody?
Yes, yeah.
Yes.
Then there comes a DevOps engineer. What is the primary role of a DevOps engineer? We have developers developing the code. DevOps engineers are basically to deploy that code to various environments, QA environment, performance environment, non-production environment, production environment. That's what the core role of a DevOps engineer, deployment engineer. It can do more stuff based on if you look at the definition, it is supposed DevOps engineers are the engineers supposed to do both development and operations work. But anyway, from the what I've seen and in the market, Indian market or in any global market, they are mostly deploying the application, code deployment in various environments is what is the main role of the DevOps engineers. And we leverage the automation, CI/CD pipeline. We do we can automate the infrastructure using Terraform. We can automate configuration management using Ansible, right? And it has to understanding of the deployment architecture. The Are we deploying in the VM or are we deploying in the Kubernetes? It changes the entire thing. I get this. I'm very excited to ask this question. I asked this question, but not everybody can answer this question. I don't know why, because I think most of you have not have doesn't have the exposure. But let's see this here. I'm going to ask this question. Do you know, friends, your application is it running in the VM or is it running in the container? Do you know this answer of this question? If yes, please use the chat option and answer VM or container.
So nowadays it was all are in cloud.
In cloud, both the things are there.
Yeah, in cloud
Is it running in the
mostly
VM or is it running in the container? Simple question I'm asking.
containers.
Okay. Because in the cloud, VM is also there, right?
But most of the people will go for containers.
But yeah, see, that's because you are thinking like this. But there are a lot of companies, they are still in the VM, legacy companies. They are trying to migrate monolithic to microservices. They're deploying in the containers. No, but I asked this question in the chat. Let's see. Good that you know, Rangnath. Others, let's see how many responses I have got. Ramiz has answered. Veena has answered. Rangnath has answered. 3 people. That's it. Don't say it is not important to know. Those who are not answering, don't say it is not important. You can say you have not got exposure or nobody has told you, but don't say it is not important. As a performance engineer, when, okay, in any company, I'll ask this question to give you better exposure. In any company, we need to do capacity planning. This guy also does capacity planning. Capacity planning, you understand, right? How much infra would be required for prod? Or what is the pod sizing? Kubernetes, if you deploy Kubernetes, what is the pod sizing, container sizing, capacity planning? It totally changes the equation when it is deployed in the VM versus the Kubernetes container, totally different. Who in the company does the load test, analyze the load testing, and can answer this question that how much infra would be required to support prod load? Who is the right person in the company? Think rationally and answer. Who has the information that how much infra would be required to support prod load?
Architect.
That's the problem. Here where the problem. How architect would know? You performance tester is doing load test. Performance engineer is analyzing the load test, and we're asking this question to architect. Poor guy has developed, has designed the architecture. That's correct. Good. But how much infra would be required for the prod load? Are we asking the question to architect? How come he would know? Or the architect would know, he or she?
So on that time, we will go for ask for the infra architect infra team.
Again, wrong thinking. Infra team can give you infra.
Okay.
How much infra I'm asking? Who should tell this? Who has this information? Who is doing the load testing? Prod load. Am I making sense to all of you? Is it the right question?
Yes, Roshan. Yeah, it was nice. Thanks.
We are not thinking the right way. Infra team will give infra. They do not know how much infra to give. Architect will design the solution. Okay, create asynchronous architecture, create synchronous architecture, create load balancer, have Kafka, have this database. Architect job is done. Developer will develop the solution. A developer is going to tell you how much infra would be required. Then we are not realizing as a responsibility as a performance engineer or a tester, friends. Right? This is the team who is doing this work. Load testing. What is the load? Prod load, half the prod load. This guy should know how much infra do I have in the lower environment, how much load I'm doing, and how much load, if to support that much load, how much infra would be required. We can do the extrapolation and can recommend with auto scaling anyway, so that plus minus buffer can be taken care. Based on our discussion, who should know the infra requirements? Friends, is it clear now? Yes, no, nobody?
Yeah, yes, Roshan.
Okay, perfect. So, okay, so friends, then we have the DevOps engineers. We are code deployment, and we leverage DevOps, leverage automation, right? CI/CD pipeline using GitHub Actions, Jenkins, Argo CD, whatever, like tools. We have a lot of tools. We can use Terraform for to automate infrastructure, Ansible to configure management, right? And it has, and these guys should know the how do we create infra, deploy application in the infra, set up monitoring for you, set up monitoring dashboard for you, set up monitoring. They do that because they have the infra, they can install application. They may not be able to size correctly. They can create infrastructure, they can deploy application, but they cannot size how much web server, how many VMs, how many pods. Poor guy cannot answer this question, DevOps engineers. Unfortunately, we rely on, but here that's where the capacity planning comes, and we should help. Okay, no, create these many VMs, create these many pods, because you know the prod load, and how much infra would be required to support the prod load, right? So we do this setup monitoring and dashboards, right? We can do that. Core responsibility, right? And we leverage automation at the core. Everywhere automation, that's what the core is. Everywhere, everywhere. I'll put this CI/CD, Terraform, everything into automation. Then we have this SRE engineers. See, now let's say that they have deployed the code to production. Okay, DevOps engineers, they have deployed the code to production. Now problem comes in production. What happens? Let's say I make my trip, Flipkart, Amazon.com, Blinkit, Zomato, Ola, Uber, and there's an issue in production. This website which we are using, Is it the most important thing to fix this problem or not right now for the company, for the Flipkart, Amazon, Blinkit, Zomato, whatever application, Make My Trip? Is it the most important thing or not? Yes or no?
Yes. Yes.
Without
Yes.
any doubt. Without any doubt. Even CEO would be interested. Okay, what happened to my website? Why it is slow? What is the problem? Why it's not loading? Why my orders are failing? If this website has a problem, Flipkart CEO will be in the call. Like I'm just telling the importance of this problem in prod. Then who should take care of prod issue, friends? Where the prod issue, who will take care of production issues? When the code is deployed to production, DevOps engineer work is done. Okay, good. They have deployed the application code 2 days back. Everything is running good. But you get prod issues. What should you do as a company? Think about it. You are the owner of the company. You are me. You are the owner of Make My Trip, Blinkit, Zomato. What you would do? What you would expect your team member to do, your employees to do? Fix the problem at the earliest. But who will you call? Entire company? All 1,000 employees? That will be a mess. And it is the most important thing. Yes or no? We all have said yes. So, friends, SRE engineers are primarily responsible to making sure that the production or the customer expectations, experience, and user experience have the smooth experience. So they are the guys who took look into production. And it's not that simple skill to have, right? Just I cannot call somebody a SRE engineer. It comes with a lot of expectations from this role, particularly for a senior engineer. Comes with a lot of expectations. I need to make sure, as our SRE engineers are supposed to make sure that the production runs smooth. When I say smooth, from high availability perspective, applicants will be highly available. Highly performing, should be secure. No compromise on security. Tomorrow, if you come to know in the Flipkart website, you uploaded your credit card, debit card, and it got hacked. Personal information. When we register, we put our address, personal details. Would you like this website to getting hacked? And hackers compromising the infra, the personal information, credit card details. They want that the company would like to expose those things? Not at all. Right? High availability, performance, security, and that too at the cost optimized solution. I don't want a solution which is too costly. So as an SRE engineer, our main goal is to give customer the best experience. It's very easy to, it very nice to hear that, but it has a lot of skills. You should be very good at troubleshooting. If there is a problem, we need to catch those issues early. I don't want to tackle the problem as an SRE engineer. I don't want to tackle the problem when it's already impacted the customer. I would like to tackle the problem before it has impacted the customer. Yes or no? I should be in a position to know, I should be able to capture the symptoms early before it makes the impact. It's like if I'm getting cough, slight cough, right? I don't have a fever as of now, but I've started to get cough, or I'm losing sleep in the night. I got up, or I'm feeling headache, body pain. I will. I would like to address that issue at that moment, not when you get the fever or when the situation is worse and you are completely ill, right? So same thing goes with the application. So we should be in a position to tackle the issues when it has not impacted the real customer. So we should be in a position to know the symptoms. So what do? We keep alerts, friends. When we get the monitoring dashboards, we capture all the metrics, CPU, memory, lot of hundreds of metrics we capture, database, SQL queries, response time, status code, overall health, uptime, errors, exceptions, throughput, just name it. If Java application, garbage collection, how GC is performing. So we need to capture all those metrics, right? And we should have the right threshold set so that we get alerts. So that's the only way to know about the problem. Yes or no? How somebody in production, if this Flipkart page is down or having some issues, how the engineers working 24/7 in the shift in the production support, how they would come to know about the problem. This will get some alerts, right? They cannot monitor all the 1,000 panels all the time. They would have monitoring dashboard. Okay, fine, get it. But they have hundreds of panels. Can anybody look into hundreds of panels all the time and being aware all the time? No, right? We should have the right alerts set up. Proactive alerting, we call it, not the reactive. So we should be in a position. So alerting is the key here. Getting alerts. Should I alert at 50%? Should we alert at 60%? Or should we alert at 90%? We don't want to too early, too late also in the game. If I alert at 90% and I don't get time to fix the problem, and I don't want to get alerted at 30%, I'll keep on getting alerts every now and then. Informational alerts. I don't want that. So alerting is the key here. We should look at the historical pattern, how the alerts, how the threshold has been from last week, last month, and we should set the right threshold accordingly. So that, okay, let's say we are observing a pattern. My CPU is usually 60 to 65%. Sometimes it goes to 68%. Sometime once in a week, 70%. That's it. It comes down. And that to 70%, it only keeps one spike or two spike. So if I'm intelligent enough, I can set up a threshold at 71 or 72% of the CPU when the CPU is 71% for 5 minutes or 70% for 5 minutes continuously. If I'm getting the CPU spike, 70% spike for the continuous 5 minutes, every, let's say 1 minute or every 30 seconds, I'm capturing the sample. If I'm continue to get that sample, I would like to get alerted. Not at 40%, not at 50%. Yes or no? Am I making sense to you?
Yes, Roshan.
And then obviously, friends, we should have a great understanding of the deployment. I'm not saying that we should know deployment, right? No. But how it is being deployed, blue-green deployment, rolling update deployment, is it deployed in Kubernetes, container, VM? What is the automation process? What is the way to roll back? I should have the understanding so that I can ask DevOps engineer, okay, boss, I see a problem with the current deployment, roll it back. I should have the understanding of things happening in the DevOps, how it is being deployed. I can, before I deploy the code, I can ask performance engineers, show me your report. I don't need to do performance testing, but I should have that understanding of the report. I should see whether have they really covered Have they really recommended? Is the application size as per the recommendation or not? See, overall thing depends on the company skill level, right? If performance engineers, testers are not doing the job correctly, and SRE engineer, nobody can do the job correctly. SRE engineer cannot do the job of a DevOps engineer, cannot do the job of the performance SRE performance testers or engineers. But if the SRE engineers are in that shoe, definitely it can give inputs. I can ask security team to show me the report for the security perspective. Did they have they scanned the code or not? What is the vulnerability level? So I can check all the reports and then I can go ahead with the prod deployment. So they are the gatekeepers, basically. They are the gatekeepers before any code gets deployed to production. And they check things. And when the issue happens, they are very good at troubleshooting. That's why I say SRE engineers are as good as the performance engineers, right? Because they need to be very good at troubleshooting. If the problem is happening, about to happen in prod, by just the symptoms, I should be able to understand whether it's a real issue or not. It's just an outlier. That's the very important thing of an SRE engineer. Very good at troubleshooting. So if somebody wants to know what is the skill set for the SRE engineer that's required, multi-skill, right? I'm talking about senior SRE engineers, right? There are in SRE team, there are basically three roles. There is something called production support. There are L1, L2, L3. I'll just say this. In SRE engineers, usually in the company, in the market, you get three levels: L1, L2, L3. L1 are the like some 3 to 4, 5 years experience. They do the production support. They work in shift. Right. Right now, as we speak, we all should understand that there would be few people in the production support of Flipkart. They would be monitoring the production. Yes or no? It is the most important thing for the company. They cannot leave as it is without, right? They need to be there, right? But they make business from this application. They cannot afford to make this application down. So they work in the shift and they monitor the alerts, and they have some SOPs, standard operating procedures they have written with the alerts, and they analyze and they work. And when things are beyond their skill set or as per the SOPs, they involve L2 engineers. So I'm talking about L2 engineers here. All the skill set that I was about to list now is for the L2 engineers. Senior, principal engineers. L3 are the subject matter expertise, like developers. If the problem is with development team, one code, L2 engineers cannot fix that code. Even L2 engineer has to involve the development team. So they are the subject matter expertise, I would say. So I'm going to list the skill set, SRE skill set for the L2 engineers, senior engineers, principal engineers, principal engineers, friends. Okay, friends. So point is, and they are subject matter expertise, SMEs, and they are they work in the shift. They are work in shift, and they are very important for the company because you need somebody, right, to escalate things. You need somebody to escalate things, to monitor things, to do some operations at a given time, right? So as the SRE engineers, I hope everybody is interested to know the skill set of the L2 engineers here, right? Yes or no? Am I correct? Am I on the same page?
Yes, Roshan.
Yes, yes.
Cloud knowledge, okay? Cloud. Again, I told you, right? We should have the understanding of the infrastructure, VM, Kubernetes, container. We should have the understanding of the architecture. If am I using S3, am I using load balancer, auto scaling group, what all components I'm using, serverless services, thorough understanding of cloud. I'm talking about L2 engineers. Okay, please be clear. Note that. I should have a good knowledge of scripting. As an SRE engineer, we should be good at scripting. There could be some activity like I need to take the database backup. I may not be doing it daily basis, but I should have the script ready, right, to take the backups. It's just a one-time activity. So I should be very good at scripting, I would say. Now, for scripting, I can do scripting in Linux or Python. I should be very good at this. Lot of mundane stuff day in, day out where I'm doing. I don't want to do it manually. Nobody likes to do manually things because we need to save time through scripting, through automation, so that we can spend that time in other important stuff. We should be good at troubleshooting. The most important skill, troubleshooting. Setting up alerts, right threshold. It's all about the right. Do you know the architecture? Do you know the technology? Do you understand the technology? Because setting up alerts is a very simple thing. If I tell you set up alert of CPU at 60%, anybody can do that. Even 11 engineers can do that. But how did you conclude it 60% is a good alert? That's important. Understanding of the application, understanding of the architecture, understanding the historical pattern, understanding the problem beyond which you need to get alerted. You don't want informational alerts. Informational alerts are very bad thing, right? Because they not just information, but they also reduce the confidence on the alerts that we get. I hope you understand, right? There could be, let's say, if you put information alerts, you get 1,000 alerts. And out of 1,000 alerts, there are 950 alerts which are informational. There are chances that you will miss out on the remaining 50. You will overlook the remaining 50. Yes or no? Able to understand this, what I just said, friends? So efficient alerting, I would use the word efficient alerting, right threshold. And that comes only with when you understand the architecture, when you have a thorough understanding of the application, right? Obviously, when I say cloud, again, nowadays people are talking about microservice architecture. We should all know that about microservices. We should all know about Docker, Kubernetes. In today's how auto scaling works in VMs and in Kubernetes. In VM and in Kubernetes, you should all know that. We should know how the deployment works. We may not be deploying regularly, but we should know how deployment works. If the problem is with the deployment that causing the problem in the production, I am interested. I cannot let the deployment process create a problem in production. Or I should be ready. We should have a process to roll back the code. Let's say we get a request to deploy the code. Tell me, think about it. All I want you to think rationally, okay? Don't you think like you are the owner of Flipkart, you are the gatekeeper. Company has asked you to please take care of his website. Would you be interested in rolling back the deployment when any request comes for the deployment? Yes or no? If any problem comes, you should be comfortable in rolling back the deployment. Yes or no, friends? It's like a normal problem, right? When you try something, When your kid has asked something, Daddy, fix this, let's say, you would know, right? Okay, if I'm not doing things better, I should not at least make it worse, right? We should have that level, right? So if any code is getting deployed, this would be in a position, okay, this having some issues, and try with the lower environment first. Let's. But sometimes it happens that issues come in production. Even if you have tried, you have multiple environments, you have tried, but you have not got the issues. But in the production only, you sometimes get the issues. So we should be very comfortable. So we should have the deployment knowledge, right? So cloud part, friends, scripting, troubleshooting, alerting, having the understanding of the microservices, Docker, Kubernetes, auto scaling in VM, Kubernetes, deployment understanding, architecture, architecture understanding. We should all understand all the components that is there in production. What all component do you have this architecture? Because the problem could be anywhere, right? If you are not knowing about a component and that is creating a problem, you're gone, right? Then you would not be able to come to you cannot find the RCA. You cannot find the root cause. If you're missing on few components, we should know the thorough understanding of the architecture, how components are connected. I hope you understand, right? When I say architecture, what do I mean? I hope you understand, right? What I mean. Like high level diagram for any website, let's say, I just for any website for a web application. Hey, just check this, like this kind of architecture. We should have the thorough understanding of the flow, how my request is flowing, different components involved, right? This setup for your company, for your website, for the if you do not have this understanding, how will you troubleshoot application? The flow. Okay, my web browser, mobile browser, I can log in, DNS, load balancer, web server. I have the application server, I have the database server, caching layer, cloud storage. I'm storing these things in the storage, data warehousing. I'm doing Hadoop and okay, fine. Content delivery network for making performance better. Okay, fine. And I should have these many web services. That's fine. Okay, good. I should have a thorough understanding. Can anybody troubleshoot application without having thorough understanding of the architecture, friends? Okay, so these are the skills required, friends. Okay, so that's all time I needed for you for answer most of your question. Please ask any question if you have. I hope we learned something today, right? That was the main intention. I wanted to make your time worth spent with me. All good. I hope we learned something. Yeah, please ask your question if you still have any questions.
Thanks for the detailed session, Rohan. So SRE is
My name is
basically,
Roshan. My name is Roshan, by the way.
yeah,
Go ahead. Go ahead.
yeah. SREs are basically only responsible for prod issues. Am I right?
Correct.
Okay.
Correct. Well, lower environment, there are people, right? QA engineers, performance engineers, security engineers. There are people.
Okay.
Yeah, if somebody is something problem happens, nobody can figure it out, you call some good SRE engineers. That's an exception thing, but they are usually expected to work in production. Okay. Any other questions?
So SREs and observability engineers both are same, Roshan?
Okay, when you say observability, observability is one of the skills of the SRE engineers. When you say observability, what does it mean? It's like analysis, troubleshooting. I'll put this skill set here. Without observability, you cannot troubleshoot. It's like observability. What does observability mean? Monitoring, having the metrics, logs, traces, and you doing analysis on top of it. Right? That is what the observability definition is. It comes under troubleshooting. When you try to troubleshoot the application, we go over such things. So one of the skills of the SRE engineers, important skill.
Okay. So SREs will only find out the root cause, or they are the responsible for fixing that issue. No, right?
No, if the problem is with the code, let's say they found the root cause. Okay, the infra issue and all could be handled, right? If the infra depends on the what problem, right? There are so many people in the company. If developer has made a mistake or has coded poorly, having bad performance, and that has gone to prod, performance engineers could not catch that, whatever it is. So they've gone to prod. And that's getting a problem, that's getting a slowness, response time in high in prod. Eventually, who should solve the problem? Ramesh, I'm asking to you. Who should solve the problem?
Yeah, the corresponding team, like developers.
Correct, right?
Yeah,
SRE engineers are not the code owners, right? Yeah, they are
correct,
the
correct.
gatekeepers of prod, correct? But they have leaked the issue, functional issue, performance issue, some security issue. They have come to prod. It doesn't mean that if it has leaked to prod, SRE engineers will be blamed for everything. No, we should do blameless postmortem. One of the important skill to do, we should do blameless postmortem, right? Blameless RCA, root cause analysis call. We do that. And we figure out the problem. Okay. Because of this code, why it got missed. Okay. Performance engineers could say that we were not or not notified or we have not considered that particular transaction, or with that load, it was not simulated because the payload could be various problem, right? Eventually, the problem would fall to that right respective team. I hope I'm making sense, right?
Yeah, correct.
Okay, friends, if you are okay, any other questions before I talk about something important for you? I'll take a minute.
Will the SRE responsible for the reliability of the applications as well, like designing the
Absolutely,
failover tests, everything?
absolutely. It comes under production. Absolutely.
Okay.
Site reliability engineering is the definition of SRE. Reliability. So failover. What happens if the primary, let's say, if the entire cluster, let's say the cloud they're using, complete AZ goes down, complete data center has gone down, or complete region has gone down, how the failover will be done? The responsibility of the SRE. Yes, absolutely yes. Failover, because that's under the purview. We do we do chaos testing here because problems can happen, right, in prod, which can never be simulated in lower environment. Sometime it happens. Load balancer going down, Kubernetes cluster going down, chaos, chaos situation, AZ going down, region going down. How disaster recovery is happening? DR, right? So we do all sorts of responsibility as part of the SRE engineers. Yes.
So what about SLO and SLIs, Roshan?
Yeah, they are words, they are terms. SLA is the service level agreements. SLO is the service level objective. SLI is the service level indicators. So there are some words, right? And we need to operate on that basis. For example, right? Let's say tomorrow, today, let's say you have purchased Workday. If everybody is using Workday, right? We use Workday or Salesforce, right? Or let's say Dynatrace, somebody has procured Dynatrace. Dynatrace would promise, right, something that, okay, or Workday or Salesforce, that I'll be available. So there are some agreements. When you procure some software, there are some agreements being made that response time would be within this millisecond, high availability, you will get uptime of this much. So they sign some agreements, right? When you purchase some software, Workday, Salesforce, they cannot just bring the, let's say, think about it. You purchase the Salesforce Workday and the application is down for a 1 day. Will you like this? No, right? So you'll have some agreements set up that, boss, I'm purchasing it. I'll be paying you 60,000 monthly or yearly, whatever it is, monthly. But I need this much. This you have to abide by response time. When I hit your API, you should be giving me uptime. You should be response time, uptime. There will be some SLAs signed, and then the companies work towards these SLAs, whatever they have defined, and we're calling it objectives. So let's say I am Workday, and I have committed that I'll be available 99.95%, or I'll be uptime. Let's say as part of the SLA, I have committed uptime is 99.99. What does it mean? It has a meaning of it. If you do not know, I'll show you. If you go to the uptime, let's say uptime calculator. So when you say 99.99, what does it mean? It means this, that you will be available. You can be only down for 52 minutes in a year. If you break it down, you can be only afford to be down for 8.6 seconds in a day. That is what the uptime means. So based on the objective, you will have some object based on the SLA, you will have some objectives set for your team. Right, boss? For your team, right? Okay, that you are committing this much, 99.9%, but let's have an objective of 99.99. And then what you do to achieve it can be measured through indicators, uptime indicators. So based on the metrics. So there are some terms that we use. A lot of terms we use in the SRE world, right? But I hope you got the perspective, right? SLA, SLO, SLA, where it fits into picture. Able to understand?
Yes, yes. And one more question. It's simple, but for my understanding, I'm asking. What's the difference between here DevOps and SRE engineers?
As I told you, right? I think I have explained that they are mostly to do with the deployment. They deploy the code. That's it. Their work is done.
Okay, before moving to production, they will deploy.
But
That's
they
it.
deploy the code in production also.
Yeah,
That's
yeah,
it.
means not in production activities, for only deployment up to
Deployment
they will do.
activity.
Yeah.
But don't think that monitoring of this is not important. This is the most important thing, right? So how the use the for how production health, customer experience, all overall health, overall experience comes under the purview of the SRE engineers. All the production things. I hope that
And
makes.
yeah, yeah. We have going for using any observability tools here.
Which tool? There are so many tools out there. You can use commercial tools,
Like
open
Prometheus.
source, Dynatrace, App Dynamics, New Relic.
Okay.
There are so many tools. Depending on the company, they select a tool. or they cannot afford, they go with open source, Prometheus, Grafana, Elastic Stack. They need to do, right? Observability. They need to capture metrics. How, if somebody asks about your health, how is your health? So you can say how you're feeling, but what is the proof? You need to get the blood sample done, ECG, EEG, whatever. There is ultrasound. So if somebody wants to know about the application health, you need to show these metrics, right? So you need a monitoring tool.
So Roshan, this monitoring tool installations and those things are also responsible for SRE. I
See,
mean,
they
for
can
example,
deploy, a DevOps engineer can deploy application, can deploy monitoring tool, set up monitoring tool. But the most important skill is the alerts. See,
okay.
installation is a one-time activity. If you Google how to install a particular software, you will get it. It's a one-day job, right? The main challenge is this guy here, correct? Or dashboards, creating the dashboard for every panel. So if you go with commercial tools like Dynatrace, App Dynamics, Datadog, New Relic, you get premium support and anybody can help you. And you need to go over the documentation depending on the tool, and you can do a lot of things using open source. Yeah, it's a one-time activity. But from the SRE perspective, the most important is the alerts. Yes, you should have the observability, definitely, yes. But having the right alerts is very important. I'm not sure how many of you can realize this importance. Do we realize this importance? I'm just able to understand the importance of alerts, friends. How
Yes, yes,
critical it
Roshan.
is.
Yeah, yeah.
How critical it is for the success for any company.
Yes, yes, yeah. Before production incidents will come, right? So we can get the alerts and we can stay alert, right? So
Correct.
before it is impacting
Alerts.
to the customer, we can fix that
Yeah,
issue.
alerts, notifications, whatever you say, you get notified. Very important skill. Right alerting, efficient alerting, right threshold alerting is the most important key. That is what SR engineers are involved in. Okay. Okay, friends. So, friends, if you are looking for the entire course, I have a course, okay, coming up. Okay. So let me introduce you about the course. We'll have a demo on this course, right? Separately. I just want to tell you, if you are looking forward for all the skill set that I have mentioned here in one place, I have a course for you, and I'm running this course from last 6 years, not today, right? We will have the demo session scheduled on March 21st, next weekend, and you go over this. There are few previous demos which we have done. You can go over it, and there are some feedbacks given by different people over the years. And then there's a course, cloud, Linux, whatever you were asking, SLIs, SLOs, right? Monolithic microservice architecture, Docker, Kubernetes, uh, performance engineering in DevOps, gaining resilience and reliability in AWS, observability, right? Troubleshooting Java applications, automation. So I'm going to just give you this link for now, right? You can go over it and feel free to join the demo session. We'll go in detail about the course in the demo session. Right? If you think it's worth, go ahead, please join that and we can discuss more about the course. Okay, friends. Any questions I can handle, I can take up more.
with this course we can crack the interviews, right? I mean, for example, I am the performance tester, so
Yeah,
I
if
can say
you
like
you are into this part, right? So you need to develop engineering, right? I can help you with a lot of stuff here, but you need to develop troubleshooting experience. Because again, I told you, right, it is something not can be spoon fed. I can give you some insights, I can give you exposure, I can show you the path, I can give you a few scenarios, right? But it's something troubleshooting, right? It takes time. And because it takes time, because it is subjective to your application. Whatever the example I will tell you may not be applicable for your architecture, right? It depends on your architecture, but you need to think in the same way. So to answer your question, yes, you'll be able to crack interviews without any problem. But you need to also spend some time, because if you are into this, if you're already into this, definitely you will be able to crack interviews, become SRE engineers. I could have told you.
okay.
Okay, friends, any other last questions for today? Okay. I hope I made your time worth spending, right? That was the goal. And I want you to take some learnings. I hope I was able to, you were able to get some insights, right? Thank you so much, everybody. We'll meet.
Thank you, Roshan.
Thank you so much. We'll meet next weekend on the demo. Thank you so much, everybody.
Thank
Thanks.
you.
Bye.